Hello viewers, welcome to my channel MathComp. Today I will be teaching all the basic concepts that you need to learn before you start solving MCQ problems in chapter 1 real numbers, which you'll be having in your class 10 CBSE syllabus. So as per the new syllabus, you'll be having only MCQs to be solved for the first term and do not have the same chapter for the second term. So, in this video, I'll be teaching you all the concepts that you have to learn before you start solving a MCQ. Okay. This is my content page. I will be teaching you what is real numbers, and under real number, what is a rational number, irrational number, natural number, whole number, integer, and all. And then I'll teach you Euclid's division lemma. In Euclid's division lemma, you'll also be learning Euclid's division algorithm. Okay. And then you'll be learning fundamental theorem of arithmetic, and then we will revise certain concepts that you need to know related to irrational numbers, and also we will be solving rational numbers, like how to find the rational numbers, decimal number, like when I give a number in the form of p by q, what kind of decimal expansion you'll obtain, how to find what kind of decimal expansion it is, what are the tricks that you can use. All these things I'll be explaining in this video. So going to the first content. What is a real number? Basically any number, anything, a integer, a whole number, a natural number, rational and irrational number, every number comes under real number. So that's nothing but any number that is represented on a number line, or any infinite or finite decimal expansion is called as a real number. So under real number, we have these main categories, that is natural number, whole number, integer, rational, and irrational. Natural number is nothing but numbers from 1, 2, 3, 4 up to infinity. Whole number is same as set of natural number plus 0. That is, it starts from 0, 1, 2, 3, 4 up to infinity. And then integer, it includes all positive and negative numbers, but not decimal numbers. Please make sure natural number, whole number, and integers does not include any decimal number. It only includes the whole numbers, not whole number, like, yeah, whole numbers. And then in integer, you'll have both the positive and negative sign. For natural number, you have all the whole number except 0. And coming to rational and irrational. Rational number is any number that can be represented in the form of P by Q, and here Q should not be equal to 0. Okay, so this is called as a rational number. If you can express any number in the form of P by Q where Q is not equal to 0, that is called as irrational number. Whereas irrational number is just the opposite of rational number, that is any number which cannot be represented in the form of P by Q is called as irrational number. Okay, so this is a small idea about what is real numbers, whole number, integer, natural number, rational, and irrational. Now, coming to the main content, Euclid's division lemma. So first, I'll read the lemma statement, and basically, before going to the statement, I'll just tell you what is a lemma and what is an algorithm. Okay. So, lemma is any statement that is already proven, and you'll be using this lemma to prove other statement. Algorithm is nothing but a series of steps using which you can solve any type of problem. Okay. So, according to Euclid's division lemma, given any positive integer a and b, there exists a unique integer q and r satisfying the equation a is equal to bq plus r, where r is greater than or equal to 0 and less than b. What does it mean? See, you would have read a step for verifying if the division that you have performed is correct or wrong. It is the same thing. Okay. Here, consider this is the divisor, dividend, and b as the divisor. Okay. Okay, a is the dividend, b is the divisor. When I do a by b, I will get quotient q, and remainder will be R. You know that division continues until the value of the remainder becomes less than the divisor. Okay. So here Q is nothing but the quotient and R is nothing but the remainder. That is what Euclid's division lemma is stating. Okay, what do you use Euclid's division lemma? I use Euclid's division lemma to perform Euclid's division algorithm. As I told, lemma is used to prove another statement. So using this, I will do the Euclid's division algorithm. Hope the lemma is clear. You have to remember this thing very clearly in order to perform Euclid's division algorithm. Okay. So now I will go to Euclid's division algorithm. So how do you perform this? Here is the steps which is clearly given. I will read it once and I'll also explain. To obtain HCF of two positive integers, say C and D, with C greater than D. There in the lemma it was A and B. Here they have just changed A to C and B to D. Okay, nothing else. No changes. Don't get confused. I will write here for your clarification. C is A and D is B according to the lemma. Okay. If I have to obtain the HCF of two positive integers using Euclid's division algorithm, then I have to consider C and D such that C will be greater than D. And then I'll apply Euclid's division lemma to C and D. And I will get the answers. I will get the value of Q and R. When I divide C by D, I will get the value of quotient and remainder. You know that. And I should make sure if R is less than 0, I should stop. If R is less than D, I should stop. Otherwise, I should continue. Okay. If R is equal to 0, D is HCF and of C and D. If R is not equal to 0, then again apply lemma. Okay. This process continues until value of R becomes 0. So first, I will perform the step with C and D. Okay. And then I will obtain, say, Q and R. Q1 and R1. Okay. Quotient 1 and remainder 1. What I'll do, I'll check if R is 0. If R is 0, I will conclude saying the HCF of C and D is a D. Okay. Otherwise, I will take in place of C, I will take the value of D, and in place of D, I will take the value of R1. And then again I will find the next thing, that is R1 into Q2, next quotient value, and wait, I'll find next quotient value and the next remainder value. Then again I'll check if this remainder R2 is 0. If R2 is 0, what I'll do, I'll conclude that R1 as the HCF of C and D, not D and R1. Yeah, it will be the HCF of D and R1. So it will also be the HCF of C and D. If R2 is not 0, again I will take the value of, in place of R1, in place of D, I will substitute R1, and in place of R1, I will substitute R2. The process will continue until the value of R becomes 0. And at that step, when R is 0, my HCF value will become the value of D at that step. Okay. Now, next I have an example problem. Yeah, here. See, this is the given number, 420 and 130. Okay. So I have taken what C is equals to here. D. This will be my Q1. And then R1. Okay. Now it is not 0. R1 is not 0. I will continue. So this will become my C value now. That is, what is it? D. D will become my C value. R1 will become my D value now. So again I'll get Q 2 and R2. Okay, Q2 and R2. Is my R2 0? Nope, it's not 0. Again, I'll continue. So, my C value will become R1 and D value will become R2. This will be Q3 and R3. Okay. So R3 is 0. So 10 is HCF. So I can also write 10 is HCF of 30 and 10. Okay, HCF of, I should write the steps. Like you don't have descriptive type now. So you can directly write 10 is HCF of 420 and 130. Simple. Come on. 130. You need not write, you will have option, you will just have to select. It has become really easy for you people. Okay, so this is all you will have to know. Okay, from Euclid's division algorithm, this is the only thing that you'll have to know, like how to find HCF and all. It's very simple. Next, fundamental theorem of arithmetic. That is, according to this theorem, any composite number, make sure it's composite number, can be expressed in terms of products of prime. That is all about this theorem. That is, I'll read the statement once. Every composite number can be expressed or factorized as a product of primes, and this factorization is unique apart from order in which the prime factors occur. So in any order, like first, wait, I'll show order. I will just explain what do you mean. Nobody should get. I will just take a number, say 12. Okay. 12 is a simple number. It is a composite number. First, I'll divide by 2. 2, 6. Now I'll go for 3. And then I'll get 2. Or there is another way to do it. First, I'll divide by 3. 4. 4, most of you have guessed by now. 2 and 2. 2, 2. So, no matter what order it is, but it is 2 to the power of 2 into 3. You change the order however you want, but this will be the prime factors of the number 12. Okay, so it is unique for 12. Not any other number will not have this prime factorization. Only 12 will have 2 to the power of 2 into 3. So any composite number can be expressed as products of prime, and this factorization will be unique. 2 to the power of 2 is 4 into 3 is 12. Always 12. It will never change. So it is unique, and it does not depend on the order in which the prime factorization occurs. That is all about this theorem. Okay, here I have given for 32,760 prime factorization, sorry. And it is like, if you multiply these numbers, you will always get 32,760. It is unique. Order doesn't matter. Any order you take, the prime factorization remains the same. Okay, so using this fundamental theorem of arithmetic, we can find HCF and LCM of given number. Two numbers, okay. Like for one number, you have to take prime factors. For second number, you have to take prime factors. And using this, you can find the HCM, LCM and HCF. LCM is least common multiple. HCF is the highest common factor. Please don't forget. Also, have written a formula here. This is one important formula, like maybe in your MCQ questions, they'll give you the two numbers and the LCM value, and they'll be like, find your HCF. For this, you need not do prime factorization and all. Okay, you can directly substitute. We know LCM into HCF is equal to first number into second number. Say, I will take 5 and 3. Okay, and I say HCF of these two numbers is 1. It is 1. Okay. What is your LCM? HCF is 1. What is your LCM? So what I'll do? HCF into LCM. LCM, I will write here. Okay. This is the number. Hope you have noted the number. I'll erase it. Okay. So what I'll do? First number is 5. Second number is 3. And then HCF is 1 into LCM is not given. Okay, so LCM will be LCM into 1 is LCM itself. Any number into 1 is the number itself. Hope you people know this. You're in class 10. You should know it. So what is the LCM? It is 5 into 3, 15. Even if you guys solve and check, you will get the same answer. So this formula is just a shortcut to easily like solve when you're given two numbers and either HCF or LCM, any one of them. Okay, so please remember this, note down. Okay, so here is one, like how to find LCM of three numbers using prime factorization method. I have just taken a clip of it. See, I have three numbers 8, 15, 1, and I'll change my color. Okay, see, 8, 15, and 20. You can take separately and do, but for else, you should. It is always convenient to take them in a single. Find the prime factors in a single group. So all three is now divisible by 2. At least 2 of them are divisible. So I'm just going to take 15 as it is down. Okay, and then 8 will become 4. And then 20 will become 10. Again, I divide by 2. 4 will become 2. And then 15 remains as it is. 10 will become 5. Now again, I divide by 2 to make this 1. So it will become 1. I take 15 as it is. And 5 as it is. Now I divide by 5. 1 as it is. And then 5 3s are 15. 5 1s are 5. Now I have only 3 left. I have to make all the 3 1 1 1. So I divide by 3, I get all as 1 1 1. Now I have to multiply these prime numbers and I'll obtain the LCM. This is the method of prime factorization to find the LCM of three numbers. Also, now let's find HCF of three numbers. Okay. So see here, I will take prime factors for each one of them separately. That is for 48, 64, and 80. It is 80. Okay. Now what I'm going to do, I'm going to take prime factors. I'll note them down. See, I'll note all these things. Okay. Now I will take only the common ones for all three. 2 is common. I took it. Again 2 is common. I took it. Again 2 is common. I take it. 2 is common here also. So 4 2s are common. The remaining are not common anywhere. So I will neglect these things. So 2 into 2 into 2 into 2. I'll not take 3 times 2 and all. This group together I'll take once. So 2 into 2 into 2 into 2. That is 2 to the power of 4. That is nothing but 16 will be my HCF. I can also do LCM in the same method. Like after finding prime factors of each one of them, I can also do LCM. I'll show how. See, LCM, first I have to take the common numbers. That is 2 to the power of 4 is common, right? That is nothing but 16. I already have that. And then the left out numbers one by one. What is left out? 3 is left out. And then 2 into 2 is left out. And then 5 is left out. So when I multiply all these things, I will get, let me multiply and see. 3 6 are 18, 3 40. So 960. So LCM value will be, I'll erase and write 960 into 960. 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 960 into LCM is nothing but 960. So you can also individually do it, or together also you can do it. It's your choice. LCM value is 960. Okay. So this is how you can find the value of LCM and HCF by prime factorization method. So moving on to the next topic. Okay, so in rational numbers, like if you would have answered descriptive questions, you should have prove root 2 is irrational, prove root 5 is irrational, and all. Maybe now since it's MCQ, I don't think it's possible, or they can ask you to write any one step from them. Okay, so just revise them once. Apart from that, the question that I saw mostly was they used to give a number, say 2 root 3. They used to give five options. Okay, 2 root 3 plus some 2 root 3. In my first video I have done, they used to give four options, and they will ask which of the following is rational or which of the following is irrational. And there was one tricky question even in my video. I told the previous video where I did MCQ on real numbers. There they had asked a question from the given option, which of them is not an irrational number. What does it mean? Not irrational in the sense rational. They have not directly given you which of them is rational. Just to confuse you, they have given which of them is not irrational. If a person who is like maybe last but one question is say this question, and the person is reading the question paper in a hurry, he will which of the following is irrational. He will see the first option itself is irrational, he will take and go. But you have to read the question carefully. This is how MCQs are meant to be. They will be given to confuse you. Please be careful with that. Okay, so here please note it down, it's very important. If there are two numbers, okay, one is rational and other one is irrational. So rational number plus or minus irrational number will always give you a irrational number. Say root 3 is a irrational number, plus 2 is a rational number. Okay, but root 3 plus 2 is always irrational. So this is the first one. Second one, rational number plus or minus rational number. 3 plus 3 plus 2. Say 3 plus 2. Rational number plus, okay, I say rational number plus 2. 3 plus 2, both 3 and 2 are rational numbers. Okay, so what is the value of 3 plus 2? It is 5. 5 is also a rational number. They will ask questions like this. A sum of a rational and an irrational number is always, and they'll give you options. So you should be careful there, okay? And then irrational number plus or minus irrational number. Root 3 plus or minus root 7. So this is always a irrational number only. Okay. Next, rational number into irrational number. Say 2 root 3. 2 root 3 is a irrational number. Next, for this you have two conditions, or even 2 by root 3. 2 by root 3. Or even root 3 by 2. All these things are irrational only. Okay. Now here for this case, irrational number by irrational number. If there are two different numbers, root 3 into root 7. Okay. Root 3 into root 7. 3 sevens are 21. I will get root of 21, which is a irrational number only. Okay. Now say both are same. Root 3 by root 3 into root 3. Root 3 into root 3. Okay. Root 3 into root 3. So root 3 into root 3 is equal to 3. So since both the numbers are equal, So if both the irrational numbers are equal, then their product is always a rational number. Even if I do root 3 by root 3, okay, what I'll get, any number. If two same numbers are divided, it is always equal to 1. So 1 is obviously a rational number. So please note down these formulas. They may ask you directly with values or by asking statements like if two irrational numbers are added or subtracted, what will be the obtained value? If it is rational, irrational, something like that. So please note it down. Next, for rational numbers, you have two type of uh, like you have two things that you have to note down here. One is about their decimal expansion. Rational number is basically any number that is in the form of p by q, and q should not be equal to 0. Okay, so here in rational numbers you have few things, that is in decimals. I forgot to mention it. You have terminating decimal. In my previous video I have explained. Okay, you have terminating decimal, non-terminating decimal. In non-terminating, non-terminating and recurring, non-terminating and non-recurring. Okay, so here there's a statement, this is 2 to the power n. Okay, if x is equal to p by q, if x is equal to p by q, it's not here, sorry, be a rational number such that the prime factorization of q is of the form 2 to the power of m and 5 to the power of m, where n and m are non-negative integer, then x has decimal expansion which terminates. That is, say I have a number, say 2 by 10. What is the value of 2 by 10? It is 0.2. Okay. Now, if I have to represent 10 in the form of 2 to the power of n and 2 to the 5 to the power of m, how can I write 10? I can write it as 2 into 5. That is 2 to the power of 1 into 5 to the power of 1. Can I write it like that? So, here it is in the form of 2 to the power of m into 2 to the power of n. So, any number which can be expressed in this form is always having a terminating decimal expansion. So, I have a number 2 by 6. Okay, let me divide 6 by 2. I will have to add decimal point. It will become 20. 2 3s are 18. Again 20. So 0.333 it goes on. So it is a non-terminating and recurring decimal expansion. That is, 3 is repeating again and again. So if the given number is in the form of p by q and q is not equal to 2 to the power of n and 5 to the power of m, where m and n are non-negative integers, then x has a decimal expansion which is not terminating. That is, which is not terminating matlab it doesn't have a finite value. It goes on continuing, and even this non-terminating decimal expansion is repeating. That is, same set of values will repeat again and again. So this is all you have for this first chapter. You have to learn all these basic concepts thoroughly so that you use it easily. You can crack this MCQs. So if you have any doubts, please do comment. I will surely clear it. If you like my videos, click on the like button. If you find it really useful, share it with your friends.